What's going on, everyone? Professor Brian back with another installment of Workout Wednesday. Today's focus is going to be on solids, particularly solving computational problems that have to do with density, atomic radius, and edge length. So I know this text is a little small, so I'm going to read this out. This was placed into the supplemental materials as a website, and we're going to look at question number 10. It says vanadium is used in the manufacturing of rust-resistant vanadium steel, right? So it's an alloy. It forms a body-centered cubic crystal, and it has a density of 6.11 grams per centimeter at 18.7 degrees Celsius. They want to know what is the length of the edge of the unit cell, and I'm going to expand this. What is the length of the edge of the unit cell? And what is the approximate metal radius? What is the radius? Okay, so we got a couple different pieces of information that we need to go ahead and get written down here. Let's see if I can write this down. So first thing that we want to look at is number 10, the density we have been given. So 6.11 grams per centimeter cubed. That's going to be important information for us moving forward. We have been told that it is body-centered cubic, which means that there are 2 atoms total in the unit cell. Okay, and lastly, it tells us that we want to know the edge length. That's what we're looking for. And the radius. All right, so if we remember anything, body-centered cubic means that we're dealing with a cubic situation where there's atoms at each 8 of the faces, but there's an atom in the center like such, and that atom is touching all 8 of the ones on the corners. Remember, there's going to be one here that's in the back, right? So the body-centered cubic means that we have 1/8 of all of the atoms on the corner and that one atom in the center. Now, remember, when we draw these diagrams, we're drawing them with a lot of space in between them, but the space is not that significant. But the only atoms that are touching are the ones in the center and the atoms above and below it. The atoms to the sides and et cetera are not going to be touching one another. And we're going to have to take that in consideration when we start trying to determine the volume here. One thing that we can determine, however, is the mass. Okay, so to determine the mass, we take into consideration that there are 2 atoms of vanadium. We use Avogadro's number to convert that to moles, and then we use the molar mass of vanadium, which is 50.94 grams, to determine the mass of vanadium. We go to our calculator, 2 times 50.94 divided by 6.02 e to the 23rd. Now we're looking at 1.69 times 10 to the negative 22 grams of vanadium are in our unit cell, okay? Because we have the value for the density, we can now determine volume using density. Therefore, volume equals mass over density, which equals 1.69 times 10 to the negative 22 grams divided by 6.11 grams per centimeter to the negative 3. That is going to give us a value in centimeters cubed and that will be 2.77 times 10 to the negative 23 centimeters cubed. Okay, so generally speaking, the radius is given in picometers. And now that we know the volume and we know that this is a cube, we know that the volume is equal to the edge length cubed. So therefore, to solve for the edge length, and again, this is basic geometry, edge length is equal to the cubed root of V. Now, if you have a graphing calculator, since we know the volume, 2.77 times 10 to the negative 23, in a graphing calculator, the cube root is here, is math 4. So 2.77 e to the negative 23, and that is going to give us 3.03 times 10 to the negative 8 centimeters. And this is the answer to the first question of the problem. Calculate the edge length of the unit cell. So we know the edge length here. We know the edge length. To determine the radius, however, it's a little more geometry that's going to be necessary. So what we need to determine the radius is we need to be able to take a look at the unit cell and realize that, and I'm going to draw this as best possible, realize that the distance across the diagonal within the cube, right, the distance across the diagonal from this end to the back atom, and I'm sorry for drawing this a little skewed, that distance involves the touching of 3 atoms, which that hypotenuse of the triangle that is formed within this cube, that distance is equal to 4r. It has to be, right? Because we have half of the sphere from this corner, the full sphere in the body, and half of the sphere from this corner. So 4r. So therefore, 4r squared is equal to, if this is A as an edge length, and we already know that value, right? It's equal to A squared. What we need to find is this value, which is the flat diagonal across the bottom of the face of the cell. Now, this value is what's important to us because this will give us the radius, and we're going to call this B, right? But to get B, we're going to use A and A, right? So A squared plus B squared is equal to the value that we're looking for. But we can't get B until we get the value of B, and we need to do that from A squared plus A squared equals B squared. So we're using 2 different triangles to solve this problem. The first one is here, which is technically 2 times A squared equals B squared, which is technically B is equal to square root of 2A. And if B is equal to square root of 2A, then this equation, so this is solving for B. Now we can use this equation, now that we have, and let me scoot this up. Now that we have a solving for that diagonal across the bottom of the unit cell, now we can solve for the hypotenuse, or for R, by inputting B as using the variable A. So we end up with A squared plus square root of 2A squared equals 4r squared. And we know A. We know A. A is equal to the edge length, 3.03 times 10 to the negative 8 centimeters. So if we look at these values, we end up seeing that 4r squared is equal to raised to 2 plus square root of 2 times 3.03 e to the negative 8 squared is equal to 2.75 times 10 to the negative 15, and that will be centimeters squared. And then if we take the square root of both sides, we end up with 4r is equal to 5.25 times 10 to the negative 8 centimeters, and r is equal to that divided by 4, and we end up with 1.311 times 10 to the negative 8 centimeters, which is equal to if we convert this to picometers, right? We know centimeters, 1 times 10 to the negative 2. So if we go meters, it's negative 10. If we go pico, it is positive 12. So we end up with 131.1 picometers should be our radius. Okay, so again, I'm going to zoom this out. First step, write down all the information that you have. Know that body center cubic has 2 atoms. That helps us get the mass. The mass then helps us get the volume. The identity of the unit cell is cubic. Therefore, we can determine edge length by taking the cube root. And from the edge length, we can do this mathematics. It's trigonometry, really. It's triangles, using right triangles to solve for the distance across the diagonal of the cube. This is only for body center cubic. The rest of the calculations using face center or simple cubic do not involve having to do 2 different triangular calculations. Realize that, and we'll do an example of that as well. Again, if you have any questions, feel free to send me an email. Again, the radius here, 131 picometers, and you can verify that online for vanadium.